Hey all, so today we are going to talk about motion in a straight line, or we call it linear motion also. So let us start with it. And this is chapter 2 of the NCERT. Now, what does it mean by linear motion or motion in a straight line? Motion in a straight line. So if you first starting with the motion, before starting with the motion, we will discuss about where do we study motion in physics. So if you think wisely, you will find that basically physics has a particular branch which is called mechanics, where we talk about motion in particular of certain object, we call the classical object particularly, right? So now mechanics itself, which is related to the mechanism of basically of certain objects, right, or point particles or three-dimensional bodies or like that. So mechanics is divided into two parts. You are already aware of mechanics. Now mechanics is classified into two categories. One is statics, another is dynamics. Right? So statics, which talks about basically the static state of the system or a mechanical system, where we talk about stability of the system and the center of mass and other things, center of gravity and its stability, vice versa. It is it. And dynamics is basically related to the dynamical behavior of the system of particle source, right? Particle or system of particles. So it's a classic. Now basically this part, which is motion in straight line, is part of dynamics. Then there is another part called kinematics. So kinematics is a part of dynamics, and which we are studying this motion in straight line, right? So let us talk about motion in straight line. So what is this motion in straight line? So what is the motion first? So motion is, if you take an object or like a ball is there, right? A ball is there. I assume that there is a ball, something like that. You consider it as a point particle, right? So point particle is some object which has very small dimension as compared to distance it travels, right? So we usually neglect its dimension. So that's why it is called point particle. Right? So here we are assuming that ball is a point particle. You can take any tiny object as a point particle, right? So this point particle, which is here, now what can you say about a ball? You can say that ball have two states only. What are those? It can be either in the stable or static state or in dynamic state, which is state of motion, right? So dynamic or state of motion is their static state when it has no motion, static. So that state is called V equals to 0 state, right? When there is no motion, particle is not moving. Now there is a dynamic state when it is moving. What is dynamic state? When V is finite. You can call it greater than 0. Right? Greater than 0. Sorry. V is greater than 0. Right? So So these two conditions are there. One is v equals to 0, v is greater than 0. So static and dynamic state, right? So static state you can write here, static state and dynamic state. Static and dynamic, right? Two categories are there, v equals to 0 and v is greater than 0, finite state. But v is nothing but the speed, remember that, vd, so it is speed with which it is moving, right? Now, so now as our object is a point particle, so it is moving in a straight line. It is also called the rectilinear motion, right? So first thing was understood, it is moving, so it is called the motion, and the straight line is the rectilinear path. Rectilinear path is the path connecting the points, right? It's a straight line path. You can say another way that the path which follows the Fermat's last theorem, right? So Fermat's principle, not the Fermat's last theorem. Fermat's principle, which says that the path followed by an object is extreme. By path followed by an object between 2 points is extreme, right? If an object is there, a point particle is there, it is moving from one point to another point. So the most probable path which it will follow will be extremum path. What does it mean by extremum? It is mean by that it can be either maximum or minimum path. So and that will be straight line. When you simplify it, you will find it is a straight line mostly. So extremum path, right? The distance between the two objects is extremum when it is straight line. Now let us go to this. So this straight line is basically rectilinear motion. So point particle is moving in a straight line, right? It means that it is a one-dimensional motion. Straight line motion is one-dimensional motion, 1D motion. We call D as dimension, right? Or straight line. So now this is one-dimensional motion. So now let us start with this motion. Let us try to find out the details of this motion, right? Now what are the details associated with the motion? If you want to find out any detail, right, a particle is moving, then what are the quantities which can tell us about the particles, right? Particle state. This velocity and acceleration, right? Along with the position. Obviously time is one, which is very significant, it is involved, right? So as time evolved, how the motion, how the things, basically parameters change, which is velocity, acceleration, position it is, right? So let us talk about it so that you can know about particle state after certain time t. So let us consider the particle is here, the ball, point particle, at certain times tx, at t equals to some 0 or t equals to some t. You take capital T, right? Capital T equals to small t, and position is actual, right? Particle is at actual position at time t equals to t. Now it start moving in a straight line, right? It reaches to a certain point x2 t plus delta t as the new time. We will call it t2, right? So you see the motion of a particle evolves with the time, right? Particle is moving and position is changing, right? So motion is evolving with the time, it is given. So now you see there can be specific condition, we are deriving for the general condition. where t can be taken as 0, and this can be taken as some other t, or like that. That is a specific condition. Now, so you have position. Now you want velocity. So if you want to calculate the velocity of the object, how you can calculate? Right? Now to calculate the velocity, what you will do? As the point particle, as already discussed, x1 t and x2 t plus delta t. Right? This is the evolution of the particle with respect to time. It's a new position. You throw a ball, and it reaches a certain position, and it is still in motion, right? So it is asked that what is the velocity of it at certain time t. That's one parameter which tells about it. Means which defines the tells about the ball, right? So this velocity which is here, how it can be calculated? You know that velocity, the first characteristic, it is a vector. Right. So it's a vector quantity. So if you know that it is a vector quantity, then what is its position after time t? Right? It is x1 t, x2 delta t. So velocity is nothing but, it is a vector. It is x2 t plus delta t minus x1 t divided by t plus delta t minus t, right? So this, remember that these are positions, we are assuming that they are all vectors, right? Where it has, and what does it mean by vector? It has modulus and it has direction, right? It's a vector quantity. So direction and magnitude. That is what a vector quantity has, right? So magnitude and direction are the two components which vector quantity possess. So direction is there and magnitude is there, right? So this direction which is very much significant here. Magnitude is obviously it is significant, but the direction is there, which differentiated from the other quantity called speed and position, or what we call position, right? And then displacement vector, right? So distance and displacement vectors, right? So this thing which is we are calculating here is v h x2 t plus delta t minus x1 t divided by delta t, right? This is called an average velocity. Right? So this quantity which it is called average velocity. Right? Now, then what is the speed then? The speed is defined as modulus of this vector v. Right? You can call it x2 minus x1 as delta x, and it's a delta t. We are assuming that this is a delta x divided by delta t. Right? Where it is delta x is nothing but the displacement. It is a vector. Right? So delta x by delta t mod. Right? Remember that what is the difference between the two? Now this is your speed and this is your velocity, right? Now let us go to another kind of velocity we call the instantaneous velocity, right? So this is average velocity. Average velocity is for a large interval of displacement divided by the time taken, delta x by delta. Now what happens for a speed at each moment of time, dx, x plus dx, x plus 2 dx, x plus 3 dx, like that, right? We have time for each x t plus dt, t plus 2 dt, and like that, right? So where dt and dx are very, very small, right? So what happens to this is called average velocity. Now let us go to instantaneous velocity. So this is clear. Let us go to the instantaneous velocity. So what is instantaneous velocity? Right? So instantaneous velocity is nothing but velocity at each moment of time, or basically each small fraction of time, right? So it is this. So just take this instantaneous velocity. If you call it v dash, I'm assuming that it is v dash. So it is nothing but x plus dx minus x, which is x plus dx is x1 minus x2, x1 and x2. Sorry, this is x1, x2, and this is x2. X plus dx, right? So rather than that, I should write it x1 and x2. T2 minus t1. Now here it is x plus dx minus x divided by t plus dt minus t. Right? So what you get here? It is nothing but dx by dt. Right? So v dash, which is called instantaneous velocity, is nothing but ds. What is dx? What is dx? But dx is very, very small. Very, very at each fractional, very small moment of So if you look at it very carefully, so you will observe that instantaneous velocity is nothing but change in a displacement with very small fraction of change in time interval, right? So what does it mean? It means that if you take this as another position as x plus dx and earlier position x, then the change in and time is t plus dt and earlier time is t, then change in this displacement with respect to the time, change in the time as dt is nothing but the instantaneous velocity, right? So how this instantaneous velocity is related to the average velocity? So instantaneous velocity is related to average velocity as it is limit delta t goes to 0 delta x by delta t, which is your average velocity, delta x by delta t, where delta x is nothing but the average, where delta represents a larger interval, right? So limit delta t goes to 0, it is v, which is average velocity, right? This is how instantaneous velocity and average velocity are related. Now let us go to the speed. You can Now let us try to understand relation between average and instantaneous velocity using the graphical representation, right? So let us assume that this is a graph, right, which seems to be something like this. So it's a it is making curve and it is between x and t. So x varies with respect to t this fashion. So there is a relation between that, and it may, this is the curve we have, right? So now this xt graph which is here is basically let us assume that this represents a path of motion of a particle, right? Right? So you assume that at x1, right, at t1 and t2 you have positions x1 and x2, right? Now so if you want to calculate the average velocity, how you can calculate it? Is x2 minus x1 divided by t2 minus t1, right? Where x2 and x1 are position set of the particle at t1 and t2, right? Now then how you can calculate then you can choose further a smaller portion, it is t3 and t4 and x3 and x4, right? So what will be another average velocity? This you can assume that p1 q1, this is p2 and q2, right? So pq, which is pq divided by position of p and q, right? Sorry, so it is for the length of the curve pq, and then p1 q1 and then p2 q2. In this case it will be x3 minus x4, sorry, x4 minus x3 divided by t4 minus t3. Now if you look at it carefully, very carefully, so x4 minus x3 divided by t4 minus t3. Now when you look at it very carefully, what you are seeing that now this separation is getting smaller, right? This displacement in both the cases with respect to time, right? That's as you get the basically you take a narrow time interval, your displacement is also getting so what does it mean? You decrease the time interval, you approach towards a more more closer intervals of distances, right? So that's why how the sharp the curve is varying in a very narrow time period, right? Because it's a xt graph, right? So what does it mean? If you understand it very clearly, it means that average velocity is basically velocity of a discrete system. Now when system moves from a discrete to continuous, average velocity changes to instantaneous. That is why we are writing at ddt, sorry, limit delta t goes to 0, v gives you v dash, right? Where v dash is your instantaneous velocity and v is your average velocity. So this is for the continuous, when system becomes continuous and when system is discrete, right? You take for the large intervals, you take for the very continuous intervals. So you have a continuous variation, then in case your velocity changes to instantaneous velocity. Instantaneous, right? So it means that this time interval, if you take ti, tj, and any time intervals are there, ti, tj, where ij is basically for any 1, 2, 3, 4, any one value they can take. In obviously j is always greater than I, right? J greater than I, right? Is always very greater than delta t. So this is one condition one must you should always remember. So delta t, that is the time difference, the time interval is must be delta t I j, j I basically, because it is t at j minus t at I, right? So this you must always remember t I t j for j greater than I is always greater than or far much more very large than delta t, which is the time interval difference between the tj and ti, where delta t is ji is tj minus ti, right? So this is so as this interval gets narrower, it is very narrow, this interval gets narrower, system changes from the discrete to continuous. So instantaneous velocity is nothing but velocity of a continuous system, whereas average velocity is nothing but more of a discrete system, right? So this is your velocity. Now we'll go to the what we call average speed. Now let us talk about the speed. Now what is speed? Speed is nothing but the modulus of velocity, right? So is this statement correct? No, it is not correct. It is not the modulus of velocity. Speed is modulus of distance or displacement divided by the time. This is the right definition that one must, which can be greater than or equals to modulus of velocity modulus of average velocity, right? Average velocity, right? So this thing one must understand it. So modulus is nothing but displacement is x1, then x2, then x2. So it may be the case that your displacement is in a different direction. So it is like one is in I direction and then in minus I direction, where I is basically a unit vector along the x if you are taking in motion in x direction. So it is x1 plus x2 plus x3 plus dot divided by t1 plus t2 plus t3, right? So this is there. This gives you speed. It's a modulus of velocity. You can assume at u, right? But displacement is also a vector. So what do we understand from it? As this is the modulus, it must be always positive. You are not taking an algebraic sum rather than only the positive sum, independent of what magnitude it has, what sign it carries, right? What direction it has. So it takes only magnitude which is always positive, and that's why this relation, which is called that this speed can be greater than or equals to velocity. As displacement, as distance can be greater than displacement, right? This is modulus, this is distance, which is modulus of displacement. Now the other relation which is there, so speed is same for the continuous system also, right? Speed equals to mod v equals to mod v dash It means that speed is same for the, sorry, for whether you take instantaneous velocity or the average velocity. So you take either the continuous or the discrete system, you will have speed will remain same. So it will not vary, right? It will remain same. When system changes from the discrete to continuous, velocity speed didn't change, right? So this is all we have in instantaneous velocity, average velocity, and speed. Now you can go and solve some of the problem based on it, and then you can come and revise it also. So if any problem arises, please do comment in the comment section, right? So that it can be discussed in the upcoming lecture, right? Please note it down.